Okay, so this is the first problem we are sharing in this event on variance. Let us read the question once together. So it's mentioned that the processing cost of diamond varies inversely as the square root of its weight. So I'm just writing this down once. So cost, processing cost, whatever, is inversely proportional to the square root of the weight of the diamond, right? And the diamond, now there's a value given. So a diamond having a processing cost of rupees 84,000. So there's a price or the cost is 84,000. When we have the entire diamond, that is broken into 7 pieces to reduce the processing cost or something. And the ratio of the weights of the 7 pieces is this. So what we can do is, instead of taking variables here, so we can just consider these are the actual weights. So we can consider the pieces as having weights of whatever unit. So 1 gram, 1 gram, 1 gram, something like that. So if you add these numbers, we have a total of 36, right? You can quickly add this up, 11144 and 916. So if you add the entire thing, you get a total of 36, right? So if you're getting the 7 pieces from the original diamond, so the original diamond, whatever it was, should be weighing a total of 36 grams. So this total weight is 36 grams. So that has a corresponding price of 84,000, right? Now, I'm just listing out these numbers as of now. I won't write 36, I'll write root over 36 because that is what we're dealing with. It is inversely proportional. So I'll just discuss one smart way to handle inverse proportionality very quickly. But before that, let's complete this other part. So once it is broken into 7 pieces, so once it is broken into these 7 pieces, now the weights are individual, right? So the first diamond has a 1 gram weight, the second one also 1 gram, and so on. The fourth one has 4 gram, the sixth one has 9 gram, the seventh one has 16 grams. So if you think about the total weight, or rather the total square root of the weight, so that is our indicate. I mean that is our factor that we are dealing with, right? So you have a total of something like this. I am writing this explicitly. You don't need to do that. This part you can do mentally also. But this is the total square root of weights that we are dealing with, right? Please understand that each of the diamond or each of the piece of the diamond will have a corresponding weight, and depending on the square root of the weight of that part, there will be a processing cost, right? So if I add all the processing costs, I'll get the final answer. So we can do it in this way. So it's very fair to do it in this way, right? So if I add all these numbers, so 111, there are 3 1s here, couple of 2s here. So this root 4 and root 4. Then you have a 3 and a 4, right? So if you just quickly add this up, so this is 3, 7, another 3, so that is 10, and 4, so that is 14, right? So initially you had a factor of 6, and now you have a factor of 14. Now, this is the part that I would like to discuss. I mean, we can do proportionality question in a lot of ways, but suppose this would have been a direct proportion instead of inverse proportion. Then what would have been the idea? The idea would have been this 6 corresponds to this 84,000. What is 14 corresponding to? That is the question. So you can use simple unitary method, right? But because it is an inverse proportion, you can treat this idea in this way, that the 6 will correspond to the new value. The 6 will correspond to the new value, which we don't know. And the 14 corresponds to this 84,000. So this is how inverse proportion works. So now you can use the same unitary method. So if 14 is corresponding to 84,000, each is corresponding to 6,000. So 6 corresponds to 36,000. So that should be the total processing cost after the pieces are generated. But we are not looking for the final processing cost. We are looking for the reduction in the processing cost. So that would be how much? The difference of these two numbers. So that is 48,000. So the answer to this question is rupees 48,000. I hope this is clear. So if you have these kind of problems, inverse proportion, so you can just correspond the cross value. So instead of having the the corresponding value as the the one that are directly related to, in inverse, you can just correspond it to the other value, the final value with the initial price, and the new value with, the initial value with the final price, something like that. I hope this idea was understood by this picture. So thank you.